Naming compounds with polyatomic ions. Poly means many. An ion means a charged particle. So a polyatomic ion is a charged group or cluster of atoms. And you can find an extensive list of them on the back of your periodic table. So you can take out your plastic sheet periodic table, flip it over, and look at those. So when you name compounds with polyatomic ions, you are not allowed to separate the ions into their individual elements. You just name them as a big group. So here are a few of them, the really common ones. So for example, we'll take nitrate. Nitrate has a nitrogen in the middle and 3 oxygens hanging off the side. And overall, nitrate's formula is right down here, NO3, -1. So anytime you see NO3 and it has a -1 charge, we call that a nitrate. So I'm putting this chart in your packet as well so you can see those charged groups. So everything with nitrogen in the middle tends to have the name like nitrate. There's a strange one over here called ammonium. There's sulfur compounds, which are yellow, and many more. Whoops. Okay, so if you're given the name of a compound, find the metal on the periodic table first and look at the metal's most common charge. It's written at the top of the group, just like the ones you've done before, or it's in Roman numerals in the name. Write the charge above the metal in the compound. So we're going to do that with this first one. So we've got potassium, which is K, and its charge is +1. So I'm just going to put a plus there. Then you need to go look up the formula for nitrate. So look that up on the back of your periodic table. The formula for nitrate is NO3, and that whole thing has a -1 charge. So +1 and -1 are going to cancel out because you have a 1 plus and 1 negative. You'll get KNO3. That's the whole compound. So it's important. Anytime you have more than 2 elements, you're going to name it like a polyatomic ion. So let's try another one. Copper 2 sulfate. So we know we have a copper with a 2+ charge. That tells us there's a 2+ charge. Sulfate is on the back of your periodic table. It's also on this chart here. So there's sulfate. It's really tiny. There it is. SO4, 2 negative. So we'll put that here. And both of those charges completely cancel out. So we'll have CuSO4. Alrighty. I didn't pick any that have parentheses, so I'm just going to add something in. So scratch out your sodium hydroxide and we'll try something else. Let's do iron 2. We'll do phosphate instead. So iron 2 and phosphate, let's see if it's on this chart. If not, it's on the back of your periodic table. Phosphate, oh, there he is. PO4 3-. So let's put that in your notes. PO4 3- or -3. Now you're going to do something a little bit different this time. When you put your iron down, you're going to put a 3 next to it because of this charge right here. Remember, the charges switch places if they're not the same charge. You're going to write down your phosphate, and we want to show that this whole phosphate, the whole entire thing, that there's 2 of those. Okay, if you want to see this in pictures, think of it this way. You have 3 positive 2 irons. So if you add all those up, that's a total of 6 pluses. And we have 2 -3 phosphates. If you add all those up, it's a -6. And these two numbers cancel out. If you're given the formula of the compound, first name the metal. Same thing that we've always been doing. Just make sure that you look up whether or not the metal has multiple charges, because you might have to put Roman numeral in there. Then you're going to name the polyatomic ion. Eventually you'll have a whole bunch of these memorized. You're going to have to take a test over the polyatomic ions to make sure that you know what they are. But for now, you can just look them up on your chart. So I like to split these in half. When people are first learning how to do this, so that way it's easier to figure out what's what. So the first name is going to be magnesium for this one. And the last name, you have to look up this whole thing in parentheses on the back of your periodic table. Or you can just look on the back of these notes, and the polyatomic ions are on the back of these notes as well. So this is perchlorate. And you may be wondering why that 2 is out there. Well, here's the reason. Here are the charges for magnesium and perchlorate. Whoops, that's a 2+. So if you put those together, you get 2 perchlorates for every 1 magnesium. That's why that's there. You don't need to include that in the name at all. Okay, for the next one we have aluminum. This polyatomic ion is on the back of your chart, and it's called dichromate. Then we have one more. First name is sodium. OH is hydroxide.